Hello everyone, welcome to our YouTube channel Testing Gyan. In our today's video, we will understand a very important and interesting concept in the field of programming, which is space and time complexity. The reason why these two are important because they help us to determine a better approach for our programming problem. So let us start and understand more about them. We will first talk about the time complexity. So if we talk about definition in general, time complexity is simply a study of time taken to run or execute an algorithm with respect to the input. And there are different ways to measure this time complexity, and those measurements are represented using various notations. So let us talk about those notations first. So these are the few notations: big O, omega, and theta. And what these notations represents. So big O is simply tells us about the upper bound of running time of an algorithm. That is, it tells us about the worst case time complexity. Then omega tells us about the lower bound of running time of an algorithm. That is, it tells us about the best case time complexity of an algorithm. And theta falls in between omega and big O. That is, it tells us about the in in between value of upper and lower bound of running time of an algorithm. That is, it helps us to determine the average time complexity of an algorithm. So this is how various notations are being used to measure the time complexity. Then there are few general rules as well. So these are the few rules. So here if you see, let's say my algorithm is taking big of 10 time, and sometime it is taking big of 20, big of 30. Then it does not mean like we will be writing it down like my algorithm is taking big of 10, because it is a study to measure the time taken to run an algorithm. It's not like some concept to find out the exact value. So if we talk theoretically, big of 10, big of 20, big of 30 all comes to big of 1. That is a constant time. We will say that algorithm is taking constant time. Now let's say my algorithm is taking big of n time. That is, n is some variable, it is taking a very high amount of time. We don't know the exact value. Okay, and some part of my algorithm is taking big of 10 time. Then overall my time complexity is equal to big of n plus c. But that will be, by the rule, that will be equivalent to big of n. That is, the bigger time complexity will be uh, considered. Similarly, if we subtract the constant value from big of n, if we divide, if we multiply, all comes together to big of n. That is big of n time complexity. Now let's say part of my algorithm is taking big of m time and part is taking big of n time. In that case, the maximum of m and n will be considered. That is big of m if m is maximum, big of n if n is maximum. And let's say my time complexity for some algorithm, my time complexity is coming as big of m into n. Okay, in that case it will remain same. It will be big of m into n. For example, like when we are having a for loop, and inside that for loop we are having another for loop, and in that we are having our statements, then our running time will be like big of n square. Why? Because n for the first loop, n for the second loop, so it will be big of n into n, which is big of n square. Okay, so these are the few general rules. After this, there is some comparison in between the various time complexity values, I will say. Okay, that is, big of 1 is considered as the best time complexity. That is, my running time is constant. Okay, then big of log n, logarithmic, is the second best. Then big of n is the third best, we'll say. Okay, which is linear time. This is logarithmic time, this is linear time. Then big of n raised to power a, that is, our power value is a constant, that is a is a constant. This is our polynomial time complexity. This is our fourth best. and then at the end we'll say big of a raised to power n. That is, our power is a variable here. So this is our fifth time complexity. This is our exponential time complexity. So if we see, this is the order of uh, from best to worst time complexity, okay, of an algorithm. Now let us see few examples to understand more about time complexity. Okay, so let's say I'm having an input array, okay, and this is the length of my array. So this is my example first here, okay. If you see here, I'm simply running one statement inside a for loop, okay. So this this for loop will execute as dependent on the number of the elements in array, that is the length of array, okay. So let's say if this loop runs n times, so in this case our time complexity will be big of n. Worst case time complexity, we are normally more concerned about the worst cases, okay. So in worst case, this algorithm will take big of n. That is, if my input array is very huge, it is having like thousands of elements in it, then it will be like equivalent to big of n, okay. Then in our example two, if you see, we are having two statements, okay. Both of these statements will take big of n, okay, in worst case, okay. Big of n for this one, big of n for this one, okay. And if we sum up, it will be like big O of n plus n, which is equal to big of 2n, okay. So if we multiply any constant with n, it will be equivalent to big of n. So at the end, it is big of n time complexity for this algorithm. In our example third, so this is the example which I talked about, like we are having for loop inside a for loop. So here, this for loop will be executed n times, and this for loop will be executed n times. So it is big O of, and it's not like if this is only possible if both are like running n times. It can be like n into m as well, okay, which remains big of n into m. If both are running n times, then it can be big of n into n, which is big O of n raised to power 2. So this is big of n square time complexity, okay. Then in our example 4, this statement is running big of n times, this statement is running big of n times. So overall, the running time for this algorithm is big of n only. Then in other case, like let's say if this algorithm is running m times, and this part of the algorithm is running n times, then it will be big of m plus n. So whatever will be the maximum of those two, it will be considered, okay. Then here, like in the fifth example, if you see here, like I'm incrementing I by 2, that is number of steps this algorithm is gonna take is basically will be halved, okay. Let's say if I'm having uh, n is equal to 4, then in first iteration I is 0, it will run this statement one time. In second iteration, I will be 2, it will again run this, okay. In third iteration, I will be equal to 4, right? So which is like condition is not suffice, so this algorithm runs only 2 times. That is, basically the time complexity for this algorithm will be big of n by 2. And by rule, any constant, if divided, then it will be again equivalent to big of n. So again, time complexity of this one is as well big of n. And in our example 6, if you see, we are like incrementing our index in terms of multiplication factor, okay. So here let us understand this one with the help of an example. Let's say when n is equal to 16, then this loop is gonna run 4 times. and when n is equal to 32, this loop is gonna run 5 times. That is, if n is 16, then number of steps are 4. If n is 32, then number of steps are 5. Now if we try to find out a formula for this, it will be like 16 is equal to 2 raised to power 4, okay, and 32 is equal to 2 raised to power 5. That is, number of steps are raised to the power. Here where 2 is the constant and k is the variable, that is the number of steps here. Now if we take log to both sides, it will like log of n equal to log of 2 raised to power k. And by logarithmic properties, it will be like log n is equal to k log 2. Then with the help of logarithmic property, let is log 2. If log is of base 2, then log 2 will be equal to 1. So it is k equals to log n. So this way we are finding a logarithmic time complexity. We found out this program is running in the logarithmic time complexity, which is big O of log n. So time complexity for this one is big O of log n. And by rule, it's it's the second best time complexity by like this comparison. So this is all about time complexity. We can come across various type of programs, so we should know like how to exactly measure the time complexity. So now let us talk about the space complexity. By definition, space complexity is a study to determine the space an algorithm can consume in terms of input. Okay, we represent space complexity with the help of big O notation. Okay, that is auxiliary space is made with the help of big O notation, and rule wise rules remain same and the comparison remains same. Okay, now let us see few examples here to understand it in more detail. Okay, so if we talk about this example here, so if you see, we are passing an input array to our program here. Okay, and then we are doing some calculations in the for loop. Okay, so basically if you say integer a is gonna take how much, 4 bytes, so it's like constant values will be added. At the end it will be a constant, so it remains big of 1. Okay, now let us talk about the second example here. Okay, here like we are not giving our input. Here actually we are creating an extra space within our program. Okay, we are utilizing some space, that is we have created one array of size 20. Okay, so our let's say if one integer is taking 4 bytes, then 20 will be taking 4 into 20, which is 80 bytes. Okay, so this is for the small one, it is fine, but let's say we are having n, like n number of integers, so it will be like 4 into n, so by property it will be big of n. For like constant into n is equal to n only. Okay, so this algorithm will have big of n because we have utilized one extra space. Inputs will not be considered as an extra space because this is something we are passing to our program. This is not something which we have created in our program. So if we are using any extra space in our program, in that case our space complexity will be changing, else it will remain constant only. So this is all about time and space complexity. I hope you guys will be able to understand it. In case of any queries, please let us know over the video comments. Thank you.